Okay, so in this video, we want to see another example of proving something by contrapositive. So here's the proposition we're going to prove here. So assume n is a natural number, then n is odd if and only if 3n plus 5 is even. So another even an odd example to keep things simple. And let's do a little proof sketch where we're going to just kind of think about the logic here. So proof sketch. And we're just going to really we're just going to sketch out the logic here. So first of all, remember that P if and only if Q is equivalent to P implies Q and Q implies P. So of course you have to prove both directions here. And so what we're going to do is that we will show, well, we'll first just show the forwards implication. So P implies Q. So the forwards implication is going to be N if, let me write this differently. If N is odd, then 3n plus 5 is even. So that's going to be our first thing. And then the second one, we're going to show that not P implies not Q, which is the contrapositive of Q implies P. Yeah, so you have to be careful here. We're supposed to show P implies Q. We're going to do that directly. And then the backwards direction is Q implies P. We're going to do that by contrapositive. And the contrapositive of Q implies P is not P implies Q. First of all, let me just write down what Q implies P is, right? So that would be if 3n plus 5 is odd, then n is odd. But the contrapositive of that is that if n is even, then 3n plus 5 is odd. And again, the idea here is that it's simpler when you're doing this odd even stuff to know that n by itself is odd or even. Then you know that n is equal to 2 times k if it's even, or n is equal to 2k plus 1 if it's odd. And then you can just do some algebra to it and see if 3n plus 5 is odd or even, right? Instead of assuming that 3n plus 5 is odd, then you have to say 3n plus 5 is equal to 2k plus 1. And you can probably make that work, but it gets a little bit messy because you have to divide by 3, and that actually does cause some annoying issues. So it'll be much easier and cleaner to just work with P implies Q, and it's the contrapositive of Q implies P. So now let's just write the proof. It's another one of these even odd proofs. We've done so many now, so it's becoming quite simple, simple here. So let's see. The forwards implication. So now we assume n is a natural number is odd. So by definition 2.2, there exists a k. We can use the quantifiers now so that n is equal to 2k plus 1. So then 3n plus 5 is equal to 3 times 2k plus 1 plus 5. We get 6k plus 3 plus 5. Yep, so which is 6k plus 8. And we need to write it as 2 times something. So that's like 2 times 3k plus 4. And so since 3k plus 4 is a natural number, we know by definition 2.2 that 3n plus 5 is even. Great. So that was the forwards implication. And now we'll do the backwards implication. And when you do the backwards implication here, you should tell the reader that you're going to do this by contrapositive. So we will use the contrapositive. So assume n is a natural number, is not odd or even, right? So by definition 2.2, there exists a k so that n is equal to 2 times k. Then 3n plus 5 is equal to 3 times 2 times k plus 5. And we want to write this as 2 times something plus 1. So we can see that this is like 2 times 3k plus 2 times 2 plus 1. If I pull out a 2, we get that's equal to 2 times 3k plus 2 plus 1. Now, since 3k plus 2 is a natural number, we know that 3n plus 5 is odd by definition 2.2. And now we're just going to point out that we use the contrapositive again. So then by the contrapositive, if 3n plus 5 is even, then n is odd. Perfect. That's the end of the proof. And again, you may want to try to assume 3n plus 5 is even and show that n is odd, but I am fairly confident that you will struggle in doing this, and it's not because it's not true, it's just because it makes it a little bit harder to prove.